Hi everybody, Lonnie here. I'm starting a new series. It's called Pi Tips. This is number 1, and it's just a series that's aimed at sharing some of the information and some of the techniques that I've used when working with the Pi system out to everybody in the community. It's just a way that I hope that I can take some of the things that I've learned, share them, and help you maybe get up to speed a little more quickly or get new ideas and new approaches to how you might be doing things with your Pi projects. So this first tip is how to get data out of your Pi system. And most people that have Pi systems have a lot of data in there, and they really want to get that data out and into other systems and do useful and cool things with it. Now I use the AF SDK as one of my primary ways of getting data out of a Pi system when we're not using standard OSIsoft off-the-shelf products. So if I'm doing some kind of a custom solution or something like that, I use the AF SDK. Now, the data that I'm usually retrieving, there's two different scenarios. One is I want to get an instantaneous value or a value at a specific point, and that's just a single value. And the second one, which is much more common, is I want to get a data set that has a start range and a beginning and end range, and I want to get all the values over that range. So there's 3 ways that happens with AF SDK, and I'll be talking about those. So let's go ahead and jump on over to the computer and take a look at how this is going to work. Okay, we're going to go ahead and open up Visual Studio here and create a new project. And this is going to be a console app, and it's the .NET framework type, not the .NET Core. Make sure that you get the right one. Visual Studio 2017 will default on the new .NET Core. The AF SDK only supports the .NET framework. So we'll go ahead and call this Pi tip getting values. Pi tip number 1, getting values. This code, by the way, will be published on GitHub once I'm all done, so you'll be able to grab that. Let's go ahead and get that project newed up. I'm going to bring in add a data reference here for the AF SDK. Okay, and I want to bring in some code here that will get us up to get our connection all set up. We'll step through this, but first I want to get a couple of references resolved here. I'm going to hit the control period, and this is using the .NET system, the system.net for our network credentials, and this will bring in a reference for our AF SDK, the OSIsoft.af. Okay, so we have so what we have here is I just have our server name and our database name defined here, and this just corresponds to my dev server. I have my username and password also set up, and then this network credentials is a Windows Kerberos authentication. So we're setting up credentials to be able to do that type of authentication. So we're going to securely connect to our Pi system, and I'm just using my username and password to create the credential. And then here I'm grabbing the Pi system that we're interested in, and this is the AF server that is called SkyPi 05. We're grabbing that system, and then I'm connecting to the system using the credentials that I've created up here. And then finally, I'm grabbing the database from that Pi system, and that database name is called MBMC. So if I come over to our Pi System Explorer and take a look, you'll see here we're connected to SkyPi 05 MBMC. And what we'll do now is we'll just try this out. And I want to do one thing. I'm going to put in our read key here so that our command window does not close on us as we're going through this exercise. And we'll go ahead and stop here, and I'll try F5 here, and we'll make sure that we're connecting okay. Okay, so here we have our database. We've got an instance of it, or we're connected to it, and we can see data. And so this is actually showing us that we've been able to successfully connect. So we'll get rid of this breakpoint. We'll go F5, and we're not displaying any text here, so we're just waiting on that key press. Okay, so we're all set up now. We're connected to this Pi system. The next thing we need to do is we need to actually grab a, I'm having a little bit of issues here with my Pi server, but we'll see if this will hang in for us. But what we want to do is we want to grab, we want to get a hold of this element number 1, and we want to get a hold of attribute number 1. And then we're going to use that to get this data set from that specific attribute. Now you're going to have your own elements and your own attributes. There's a lot of different ways you can locate elements and attributes. But let's see if I can get to this. Nope, it is not going to be helpful. There we go. Okay, so anyway, there's a lot of ways you can get to elements and attributes. I'm going to show you a really simple way to do it in this example, but there's a lot of sophisticated ways that you can search off of templates and stuff like that. Let's go ahead and bring in some more code because I want to get to, I want to step you through this because I hate examples that really don't show you everything. But at the same time, I don't want to make this video any longer than it needs to be to get to the tip that we really want to get to. And so this is kind of a bonus material that'll help us kind of get set up. So here is some code that is just literally stepping through the elements, and then it's finding getting a hold of element number 1, and then it's stepping through the attributes, and we're just listing that out in the console window. So let's take a look at the first thing I'm doing is I'm working off of this AF database here, and I'm looking at all the elements. I'm iterating through these elements, and I'm displaying all those element names. So let's go ahead and comment out this stuff and just see this first part run, and we'll see what that looks like. So here you can see area 1, element 1, 2, and 3. So we're seeing that, and if we come back over to our Pi System Explorer, you can see area element 1, 2, and 3. So we're just really referencing those in the array of AF off of our root path. Okay, so the next thing we want to do is we're going to do this. We're going to select an element, and then we're going to look at its attributes. So here, I'll uncomment this, and we have, I set up our selected element. I've called it element number 1, and then we've actually, then we're grabbing that element from the elements array off of the root elements that are available. There's one called element 1, so we should have that populated. And then I'm going to show the attributes for that element. The selected element, I'm going to just iterate through the attributes, and I'm going to display each attribute name. So let's go ahead and take a look and see what that displays. So here's our 3 elements once again, and then we have our attributes for element number 1, we have attribute 2 and attribute 1. And once again, let's come back and look. Here you can see here's our 2 attributes. Okay, so we're pretty much, we're very close now to being able to make our calls to this attribute. I want to look at attribute number 1 here. So same thing, I'm just going to repeat that pattern that we have for the elements. And let's uncomment this stuff. Okay. Be nice if I stop the application. And here we have our selected attributes. Our selected attribute is going to be called attribute 1, and then we're using that in that list that we have of selected off of our selected elements. We're just getting that attribute, and now this is the attribute that we're going to do the interesting work with. Okay, so bear with me. We're just about ready to jump into the heart of this whole exercise. So we're going to come back to the Pi System Explorer, and I want to do a couple of things just to help explain what it is that we're going to go through here so everything will make sense. The first thing I want to do is I want to look at the AF SDK reference. If you've seen any of my videos in the past, you know that I like to point people towards the documentation so that you know kind of where to find it, number 1. Notice it's there, number 2, and then get all the details that I can't tell you about because these videos would go on and on and on. This SDK is very extensive. So here I'm going to do a search for AF data because that's the that is the part that we're going to be using. This class, here's our AF data class, and I'll go ahead and locate that, and we can see here that we have these properties and methods, and what I'm really interested in is I'm interested in these methods. And going back, well, let's look at the high level class here. This is AF data is associated with a single AF attribute. And this is the way that you're going to retrieve historical data. So that makes sense, right? Coming down here, we want to look at interpolated values because we're getting more than one value. And this is similar to the sampled data that we are looking at. And then there's plot values, which is here, and this is same as the plot values here. Let's come back over here just so we can compare that. And I think I'm going to still have problems connecting to my Pi server, unfortunately. So we'll let that think about it for a second here. So we have our plot values, retrieves values over specified time range, suitable for plotting, number of intervals. We've talked about that. And then we have our recorded values, which is giving us those intervals. So, I'm sorry, the recorded values is giving this exact values that are actually stored in Pi. Returns a list of compressed values from the requested time range. Okay, so we're gonna try those three out and compare those to what we're seeing in Pi System Explorer. But here is the AF SDK reference. And a real quick side note is that what we're doing here is for a single AF attribute. There's also if you need to do it for multiple AF attributes, you can use what's called the AF attribute list here, and this also has this. You can go in and you can use the AF data along with the AF attribute list to do several calls at one time if you're trying to do this for several attributes. But in this case, we're only going to do it for one. Okay, so coming back here, let's see if I can get to our time series data. There it is. So we have our archive data, which is going to be the recorded values. We have the sampled data, which is going to be the interpolated values, and then we have our plot, which is plot. So they've changed the names within the Pi System Explorer, maybe to make it easier for people to think about it. But in the SDK, there's a lot of history with using these three methods, so I don't think they wanted to change it so that they can support backwards compatibility with any code that's been written in the past with other SDKs or something like that. I don't work for OSIsoft, so I can't say for certain. So here we go. We're going to one other thing that I wanted to do here is I wanted to set up a time series that or a range here, the start and end time. I want to set that up so that we can actually compare data, exactly our calls to what we're seeing in here. So what I want to do is I want to start here. I want to have my end time today, which is actually at 0 o'clock, right at the beginning of the day. And then I want to go back one day from today. So this will be actually yesterday, 24-hour period from midnight to midnight. And if I do that, I can do today, and I can minus go back one day. And if we refresh that, we can see here under let's look at our sample data here. We're starting at midnight on 5/9, and then we're ending at midnight on 5/10. So this will be the range that we're going to be using when we set up our calls. Okay, so here we have our attribute that we want to make our call off of. So the first thing is, let's go ahead and set up those ranges. We're going to call this val. We want to go ahead and set up our start range, and we wanted to use this is going to be a date time, and we want to do today, which is the same thing. That's going to be midnight last night. So going back, in my case, it's it's about 12 o'clock, so I'm going back about 12 hours or so. And because this is a start time, we want to go back 1 day from there. So we're going to add days, and we're just going to go back -1 day. Okay. And the same thing with the end time. We're just going to do our date time, and we want to do it today. And we could do that, or another way that we could do this is we could just take our start time, since we've established that, and we could do an add days to that, and we could just add a day if we want. So either way will work. Let's go ahead and go with this way. I kind of have a habit of doing that because sometimes if I do now, I want to start building off of the date time has a function called now, and it'll give you the exact current time. And then I like to use that if I'm doing addition or subtraction off of that, so I'm not getting a new starter in a new current time ever. I'm always using the one time that I grabbed it, and to set up my second time range. So here we're going to go ahead and we are going to set up a time range, because we're going to need that when we start making our calls. And this is going to be using AF time range, and I don't believe I have that as a reference. So let's go ahead and do this. It's going to be AF time, and that just put AF time up here, by the way. And then here we want to go ahead and we want to set up, we want to use our start and end. It requires 2 dates. And the last thing that we want to set up is we want to set up a span, which is going to be used when we're dealing with our interval time. So when we come back to our this, and we have this interval here, this is a span, so span of 5 minutes in that case. So that's the last thing that I want to set up. So let's go ahead and set up a span, and the span is going to be AF time span down here, and that is going to take exactly what we're seeing in there. So we could do 5 minutes, or we could do 1 hour. We're going to do 1 hour because I don't want to see a ton of data coming back. I want to be able to oh, and I need to parse that. There, that should be. So parsing it, there's a lot of features and functionality around AF time span, time range, that I'm not going to dive into here, but it's all in the SDK documentation. Okay, so we have those. Those are all the parameters that we're going to need when we make up these calls. So let's go ahead and do the first one, which I believe is recorded values. So here we can just do this. It's going to be pretty simple. AF values. Yeah, let's do values, and we're going to take that selected attribute that we have, and then we're going to use data. That's the AF data class, and then we're going to do the recorded values right here. And now we have our various attributes that we need to feed in. So we're going to feed in that time range that we have set up first of all, and that's the AF time range using that start and end time. And then we're going to do the boundary type. And the boundary type, there's a few different options if you want to contain outside, values that are outside or inside, the boundaries, if they exist. There's a bunch of different rules and technical things. It's all in the documentation, so I won't dive into exactly how you might want that set up, but we're just going to do, what I want to do is I want to do the inside. So we'll do the boundary type, and actually, let's do it like this. OSIsoft AF, or if I could just do data dot, no, I think it's going to have to be unique. AF data, there we go, AF. And we're going to do, we'll do inside. And that's just going to give us values inside that time range. We're not going to get anything outside of that time range. And then the unit of measure, I'm going to set that to null. That'll just give us the default unit of measure. And the filter expression, same thing. I don't want any filters, so we're just going to set that to null. And then do we include filtered values? I'm going to say false. In this case, we're not using the filter, so it won't really matter. And then there's also a max count that we can set up as an option, but in this case, I'm not going to worry about the max count. So we should, using that, we should get our recorded values over that 24-hour period. We're not using that span yet, so that's not coming into play, but we are using everything else. So let's go ahead and do a for each. And what I want to do is we'll do AF value, and we want to look at our AF values. Values, and let me change this to values. Okay, and the last thing is let's go ahead and do a console write line, and I want to go ahead and show the time, which will be our first parameter. And then let's do a tab with an escape character, and then let's do our value, and we'll do our second parameter. And then let's go ahead and do, let's take our AF value here, and we'll do the timestamp, and we'll do AF value, and we'll do the actual value itself, and we'll see what those look like. So let's go ahead and run this and see what happens. We should see a list of values if we're successful and there's not any errors, and then we'll go in and we'll compare that to what we're seeing in PI System Explorer. So here you can see we're starting at 12:03 a.m. because we're inside the boundary type. There wasn't anything right at 12. The first value is stored at 3:31 a.m. and that's a 97.39. And then we can come down to the end, our end value, which is, let me come up. All right. Our end value, which was 11:51 on the 9th. And that was 199.56. So we can see these two end values, and then we can see all these values in between are being stored. So let's switch over to our time series data, and let's look at this is our archive value today minus, let's go ahead and let's go ahead and do today minus 1 day. And then let's do today, and let's see what we have for our values. So here you can see we have the same thing. At 12:03:31 we have that value, and then coming down at the end we have that 11:51, we have 199.56, and then we have all those values in between. Now we have 232 values. So what I'd like to see, I'd like to do a quick check just to prove to everyone and myself that we actually are getting all of those values. So let's do the last thing here. Let's do a console write line, and let's go ahead and put our count, and that's going to be this is going to be our AF values dot count. Okay, let's run that one more time and make sure that we're seeing the 232. Was that? Yeah, 232. There we go. So awesome. So that is the first one, and we're getting those recorded values. So let's go ahead and do the next one. I'm going to go ahead and comment out that, and then we'll set up our next one, which is going to be our AF values is going to equal selected attribute data, and we want to go ahead and let's get the interpolated values next. Okay, so here's our interpolated values, and same thing, we want to throw in our time range, and now we want to use that span. So we're going to do the 1 hour, and we'll do a span, and then we have our unit of measure, which we'll set to the default. Same thing with this filter. We're not going to use filters, and then including filter values false. So it's very, very similar to the other call, but now we're going to be getting values every hour on the hour. So we should see a beginning and end too. So let's try that and see what it looks like. And we're doing 1 hour, so we should see a small number like 24 values, 25. So there we go. We have 12 a.m. to 12 a.m. over 5/9 to 5/10, 25 values. You can see what all of those are, and so it's giving us a value every hour. And then if we come here and we look at our sampled value and we do 1 hour, we can go ahead and take a look at that, and we can take are we matching, and it looks like that's matching. We see every hour coming in, and then we can see at the end we can see that that matches too. So this is great. We're exactly right on track with what we're seeing in our PI System Explorer. Okay, the last one, which is one that I actually use quite a bit because a lot of times I'm just displaying data. And let's go ahead and comment out that, and we're going to use that plot values. So this is going to be and we're just going to do the same thing, use that attribute that we have, data, and this time we're going to do plot values. And in the plot values, you can see that we also need a time range, no surprise there. Now we're using intervals, and this is, you know, we're talking about how much data we're going to display over a number of pixels. So usually if I have like a graph and it's going to be 100 pixels wide or 200 pixels wide, that's what I want to set the interval to. So let's go ahead and just set it to 100, and then same way the unit of measure, we're not going to specify one. And that is it for plot values. Very simple. Now this is going to give us values that the PI System is going to give us values that best represent the graph or the trend that we want to display. And you could use this for spark lines, you could just use this for super detailed, very high fidelity, exactly showing you what the actual trend is within, based off the recorded values. So let's go ahead and try this out. And you can see we have 207 values. So actually not, it's slightly less than what we have for recorded values. And then you can see that we're starting at 12 a.m. and we're ending at 12 a.m. the next day, so we're getting right on the end there, which makes sense because we want to get a complete graph. But some of these values are interpolated, and it's showing us, trying to give us the best data possible. So let's go ahead and take a look at our time series and go to our plot, and then we set that up as 100, so let's go ahead and refresh that. 207 values, and we can look at the end value, and we can see that, yeah, it's right on there. Okay, so we've got exactly the data that we're seeing in PI System Explorer, but now we're getting it within the SDK. So just to summarize really quickly, there's the 3 types of data, ways that we can retrieve these sets of data. The recorded values, which is going to be that data that's actually residing in a PI archive. The interpolated values, which is going to give us data at a very set interval. So it could be 5 minutes, 10 minutes, 1 hour, 1 day, 1 week, 1 year. It'll give us a value. And then the last one is plot values, which is kind of a hybrid where it just uses the best available data possible to give us something that really is intended to be used to display some kind of a graph or some kind of a graphic. So I think what I found is when people want to know recorded values, they're looking at, a lot of times they're looking at lab values, values that people have manually entered, and they want to have exactly the data that was entered, and they want to know that, hey, that's in the archive. Usually compression exception is turned off for those kinds of values because you want to actually get the data that was recorded in the PI archive. So there's a lot of situations where you're going to use recorded values and you're going to set it up, that tag to be kind of used as a like I said, lab values or something like that. Interpolated values is typically what gets used when you just need clean data points. You're going to maybe create, show stuff in a table or whatever, and you want everything to kind of line up and look nice in a report or something like that. And then plot values, typically you'll use that just for displaying some kind of a trend. So those are the 3 ways. I hope that this made sense, and it's going to get you going on how to retrieve these values, time series values from PI using the AF SDK. My name is Lonnie. This is tip number 1, and I'm hoping to have more tips in the future. If you like this video and you'd like to see more tips, please give me a thumbs up below, and also in the comment section, if you have something that you think would be a really good tip mostly around the AF SDK or Pi Web API or CoreSite or something like that. Let me know what interests you, and I will try to get to it. Okay, have a great one, and I'll talk to you later. Bye bye.